algebraic approach. You guys miss algebra, don't you?
Yes.
Yeah, so let's get to the algebra piece. Today you're going to get the thick of algebra. There are three ways in which we do calculus. You do it by looking at the graph, looking at the table, and looking at the algebra. Those are the three ways. You've seen the other two so far. They're very, 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 very specific in calculus curriculum that you look at all three approaches. So let's look at the algebra right now, okay? This is saying the limit as x goes to a of f of x plus g of x is the same as the limit as x goes to a of f of x plus the limit as x goes to a of g of x. Now, I'm not going to write that down for every single piece. I'm just simply going to give you an example, and then we're going to move on from there, okay? Because it's very intuitive. The idea is, suppose you have the limit as x approaches 1 of x squared minus 3x. Suppose that's a limit that you're trying to calculate, okay? You can simply treat this as the limit as x goes to 1 of x squared minus the limit as x goes to 1 of 3x. Or in other words, 1 minus 3 is negative 2. So you could take the addition of limits and break it up into two pieces. The same thing for subtraction, okay? Same thing for multiplication. Same thing for division. One useful thing that I like to use from time to time is if you see a constant in front of a function, you could take the constant times the whole limit of that function, okay? So you can pull the constant out front. And so it all follows according to how you think it would, okay? There's nothing that's complicated here, but these last few, I want to make sure that you understand because this is a little bit more conceptual. Hey, stop that for crying out loud. The limit as x goes to a of a constant. What does the graph of a constant look like? Horizontal line, right? Yeah. And so suppose we have something of this nature. Suppose that we have, I'm going to scroll down here. Suppose we have the limit as x approaches 1 of 3. That would mean that my function looks like this, right? So as x approaches 1, what does the y value approach? 3. As x approaches negative 2, what does the y value approach? 3. See how it's always just going to be that constant value? So if you have the limit of a constant, the answer is just simply the constant. Wow. Let's think about the limit as x goes to a of x. What does x look like as a function? Line like that, right? Where the x value is the same as the y value all the time, right? So as x approaches 2, the limit approaches 2. Yeah. So as x approaches a in this situation, the limit approaches a. In general, if you really have any polynomial, notice x to the nth power, it's a nice behaving function. You can simply just plug a in for x, and so this becomes a to the nth power. Sorry, it kind of looks like an R. And then for number 10, suppose you have the nth root of something. Root functions behave very well. You can have the nth root of a. And remember that if you have a function that involves a radical with a different index, that's the same thing as the limit as x goes to a of its f of x raised to the 1 over n power. So somebody was asking the other day how do we type a cubed root in our calculator. You don't always have to type in cubed root. You can type in to the 1 over 3 power. That's the way you can treat that. Okay. So direct substitution for a polynomial or a rational function, the idea is simply this. If you want to be able to evaluate a function in polynomial or rational function situations, you can simply plug in a and you get f of a. Super easy way to identify the limit. So let's look at a couple basic examples, and we'll get to the little bit more challenging algebraic expressions here a little bit. But it says, given that the limit is equal to 6, the limit of g of x is equal to -2, and the limit of h is equal to 0, find these following limits. So the limit as x goes to a of f of x plus g of x. I'm only going to write this out once. It's the same thing as limit as x goes to a of f of x plus the limit as x goes to a of g of x. So it's just telling us that we can break it up into two parts. What is the limit as x goes to a of f of x? It is 6. And what is the limit as x goes to a of g of x? -2. And so the limit is 4. That's it. Okay? In this situation, we have the limit of f of x, which is going to be 6, divided by the limit of h of x, which is going to be 0. Please be very careful when you're dividing by 0. We're going to look at two more critical examples of this tomorrow. Dividing by 0, this is not the same thing as 0 divided by 0, okay? You do not say it does not exist. You simply don't know. Even using the term undefined is not necessarily accurate. We need to know more about the situation in order to evaluate it. So if you get 0 in the denominator, we're going to talk about that situation a little bit more down the road. Here we have -3 times g of x plus 5. So we just need the limit as x approaches g of x, which according to this is -2. So this just comes out to be -2 times -3 plus 5, otherwise known as 11. 11 is my limit. Please try letter D on your own. Try letter D on your own. Rosa, where do you think Danny was this morning?
I think she probably was doing something really important.
Really?
Like,
Brushing her teeth.
she was getting ready. I was here on time. And she was definitely here on time, and
She
the
was
bells
here
are
on time for
wrong.
the first time.
Yeah, the bells are ahead.
Interesting.
I see that.
Thank you for your thoughts, Danny. Everybody get 6? Okay, super easy. Okay, flip it over this side. I like this example better, ties in what we were talking about with our graphs, and then moving into these expressions. So the graphs of f and g are given. Use them to evaluate each limit if the limit exists. If the limit does not exist, please make sure that you explain why. So it says the limit as x approaches 1 of f of x times g of x. This is f of x. What is the limit as x approaches 1? It is 3 times. Now I need the limit as x approaches 1 over here. What is the limit as x approaches 1 of g of x? It is -1. So this limit is -3. I like that type of a question. You're asked to use the algebraic piece, but you're also asked to look at it graphically. See if you do letter B on your own. Try letter B on your own. If you need to estimate, just estimate.
Let's see.
Did you get 11? Okay, so I got about 2.5 here, times 2 is 5, and I got -2 times 3 is 6. Okay? Let's look at letter C. Letter C says g of x divided by f of x as x approaches 2. So I'm going to first do my g of x 1, and I go over here, and I'm going to approach 2. I approach 2 from the left, and I get 0. I approach 2 from the right, and I have this barcode function thing going on here. So what's the limit as it approaches from the right? does not exist. And if it's from one side 0 and the other side does not exist, that means that the limit of g of x, in fact, does not exist. Divided by whatever, doesn't matter. If one part of it does not exist, then the whole thing does not exist. Okay? If does not exist comes up in any way, shape, or form, then that will be the answer. Please try letter D on your own. Just a little bit different for D, see if you can figure it out. Think critically. So I saw the limit of f of x was 4, and then the question is, well, what do you do about this 2x squared thing? We'll just plug in 5 for the x, and that'll produce it for us. Very good with that? Okay. Evaluate the following limits if they exist. Limit is x goes 1 of x to the 4th minus 3x squared plus 1. It's a polynomial. Just plug in the 1. I have 1 minus 3 plus 1. That gives me -1. That's my limit. You don't want to get that one wrong on the test, do you? Nope. Next one, you plug in 0. It's a radical function, no big deal. So we've got the limit as x goes to 0 of the cubed root of -27. Can you take the cubed root of a negative?
Yes, you can.
Yeah, you can. Thank you. You get -3. I'm going to try plugging in 3 here. I plug in 3, I get 9 minus 9, which is 0, divided by 0. Uh-oh. The essence of calculus, right? We looked at tables, how to identify this before. Let's look at the algebraic approach. Can you factor the top?
Yeah.
To what? Yep. We will not do a review of factoring in this class. If you need a review of factoring, come and see me. But you should be excellent at factoring. I saw you guys do college algebra last year. Those are gone. And now you can simply just plug in the 3 and you get 6. That's the limit.
What?
Yep, 0 divided by 0 came out to be 6. This situation, you plug in 0 and you get 0 minus 0 over 0 minus 0. I get 0 over 0. Oh boy. What now? Factor on x. Limit as x goes to 0 of x times x minus 5 over x times 1 minus 4x. Be careful with your positives and negatives. Notice that the x's divide, but as you plug in 0, what do you get in the top? -5. What do you get in the bottom? 1. So the answer is -5. People see how somebody might make a mistake to write +5? So be careful in that situation. Uh-oh, letter E. I try plugging in 0. And I get 0 minus 2 is -2 squared is 4. So I get 4 minus 4 over 0 or 0 over 0. So that means that there's hopefully some way to cancel something off and reduce. I'm going to square out the h minus 2. If you square that out, what do you get? Minus 4h plus 4 minus 4 all over h. What do you notice? 4's reduce. Now what? Take that h out. So we factored the h out. Jacob saw that because he said, hey, I want to reduce those h's. You now plug in 0 and you get -4.
There you go, Jacob.
I got a cube one. Cubing is more difficult, isn't it? But Haley remembers the Pascal's triangle, doesn't she? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Somebody give me the next line. 1, 4, 6. Yeah, so we can cube this out pretty quickly. We know it's going to be h cubed plus, anybody know what comes next? 3h squared plus 3h plus 1. If you cube h plus 1, that's what you get. Okay, that's what you get. We have a minus 1 all over h. What do you notice? Yeah, the 1's reduce. At this point, you can take out an h times h squared plus 3h plus 3, all divided by h. If you plug in the 0, you get 3. Yeah, notice how things that have an h, when you plug in the 0, they just disappear, don't they? Yeah. Talk to the person next to you. What would you try for letter G? I'm interested. Talk about what'd you try? Go.
What she said. Yeah.
All right. What is your thought? You know, I was thinking the other day about some of our limitations in factoring. And I was thinking how, for example, x squared minus 25, everybody knows how to factor that, don't they? And that factors to x minus 5 times x plus 5. They say, well, it's the difference of two squares. And I was always bothered by that because I said, well, like the number 25, that's a perfect square. But suppose I had x squared minus 21. And so people say, well, 21's not a perfect square. Well, I get it's not a perfect square, but it does have a square root, doesn't it? I mean, couldn't x squared minus 21 be factored to be x minus the root of 21 times x plus the root of 21? So I think sometimes we discriminate in our factoring techniques when really they probably apply to a lot of different things. So I'm going to take that approach right here, and I'm going to say, you know what? I think that this factors. I'm going to say that the top is, in fact, the difference of two squares. I have 1, and I have 1. And then what do you multiply by itself to get x? Plus the square root of x, and minus the square root of x. I'm going to argue that the top is, in fact, the difference of squares as well. And that helps me out because I can see that it reduces with the denominator right away. And now I can plug in the 1, and I get dos, which is Spanish for 2. We're going to do two more examples. We're going to do letter H and letter J. Let you guys get started on your assignment, then at that time we're not going to do I. H is different altogether. We've now learned that you want to reduce something. You want something to cancel. And if you recognize here in this situation, if you were to plug in 0 right away, you get 0 plus 9 is 9. The square root is 3. So you get 3 minus 3 over 0, or 0 over 0. And you've learned at this point that we got to do something to get rid of that 0 divided by 0, don't we? So in essence, we've got to get rid of the h in the denominator. So it's going to have to cancel with an h in the numerator. Well, that h in the numerator is tied up with the square root. So how do I free it up? That's a thought. Usually everybody turns their mind to squaring it. And I want to be clear. If you have, say, x minus 1, the square root, is equal to 5, then yes, you could square both sides. Do you see what I'm saying? Because you're providing equality. But there's no equal sign, is there? And so just squaring it provides that an unevenness within our expression. And we don't have anything to offset that. So in fact, we can't do that. So we're going to do something else. When we don't know how to do math, what do we do instead?
Sing.
Come on, I set this up for you last year. When we don't know how to do math, we do Spanish. We do Spanish. What kind of Spanish do we do? What do we do in Spanish? We What happens when we change a verb in Spanish? What's that called? Conjugate. We conjugate. We multiply by the conjugate. Remember? Watch how great this is going to work. I'm going to multiply by the square root of h plus 9, and it's going to be a plus 3. Remember, conjugate means to change the ending. So we change the ending from a minus to a plus. And in mathematics, multiplying by the conjugate is this magical thing. Got the same thing at the top as I do on the bottom because this expression is then equal to 1. But I'll only show this once here. A minus B times A plus B. Does everybody agree that those are conjugates? And when you multiply them, remember you got A squared, you've got plus AB, you've got minus AB, and then you've got minus B squared. So remember when we multiply by conjugates, the middle just disappears and the ends end up both being squared. So that's what we want to do. We want to square it. We thought that's illegal until we did that. We're like, yes, good idea. When you don't know how to do math, you just do Spanish. Let's go. Is anybody taking a Spanish class right now? Oh, how disappointing. I love it when you guys go back down and tell your Spanish teacher, say, yeah, we did Spanish and math today. They're like, what? So let's go ahead and multiply. We have to FOIL out this expression. The square root of h plus 9 times the square root of h plus 9? H plus 9. What's going to happen to the middles? They're going to disappear. Sweet. And then we end up with negative 3 times positive 3. Negative 9. Oh, that looks nice, isn't it? Yeah, I really like that. Now the denominator, this is where people get kind of crabby. Like, oh, the denominator is so ugly. Well, beauty is in the eyes of the beholder. I think it's kind of cute. We got h times the quantity, root of h plus 9 plus 3. And the reason why I really, really like that is because I can see that the 9s reduce to 0, but then what else reduces? H over h. That was the whole goal. We said we got to get rid of the h in the denominator. Now it's gone. So we have to limit it as h goes to 0 of 1 over the square root of h plus 9 plus 3. Plug in your 0. And we get 1 over 6. Sweet. Pretty cool. All right. Last example. Please take out your calculator. I want you to look at this. As you type in -5 here, you would get 0 over 0. But remember, if we want to try to simplify this algebraically, when we remove an absolute value sign, we have to set up both a positive and a negative. And in this situation, x plus 5 divided by x plus 5 is 1. And negative x minus 5 over x plus 5 is going to produce -1. Let's see how that works with our graphing technology. So have that calculator out. I wonder how much time in my life I spend signing in. That's what I want to know. How much time do I spend signing in?
I want receipts right now.
I want my money back.
At least 2.
At least 2 minutes of my life?
At least.
Minimum.
More like 2 years of my life. All right, so we're gonna type this in our calculator. I have the absolute value of x plus 5. The way we could grab an absolute value, you have a couple options. You could grab it in the math area if you go over to numbers and do absolute value. The other way is to do your catalog. That's the way I like to operate because it's the first thing that pops up, ABS. It's not analog braking system or airbag system. Maybe you have an ABS light on their car.
Where's the catalog again?
Catalog is 0, so second 0. I press enter on ABS, and I do x plus 5, parentheses, and then I divide by x plus 5.
Ouch. Oh.
And I'm going to consider the graph. And as you look, as x approaches -5, what's the limit from the left? -1. What's the limit from the right? 1. And that sets up with what I showed algebraically. And so what is the limit here? Does not exist. The left is not the same as the right. The limit does not exist. Go Mean Girls. And that's that. You guys will be ready for your next assignment, which is calculating those limits. Again, you got a lot of algebraic pieces. Some of them are challenging. I didn't show you every single kind of problem. It makes you think about some of those on your own a little bit, okay? Last assignment tomorrow. I'll get you guys a study guide in your hand. Test next week, Thursday. You guys are going to rock it.